Welcome to the Passive House Podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House Podcast.
Welcome back to the Passive House Podcast. I'm Matthew Cutler-Welsh, coming to you from Tamaki Makaurau, Auckland in New Zealand, and I'm joined by Zach Semke in Seattle. How are you doing, Zach?
I'm doing great, thanks.
And we've got Mary back with us again. How are you doing, Mary?
Very well, thanks.
And officially this is episode 200, so congratulations, team. Good effort.
Indeed.
We've done way more than 200 episodes, of course, because we've all done sort of additional bonus episodes, and Mary and Elka, you've done a whole ton of extra interviews at conferences and that sort of thing, but nice to acknowledge that nice round number of 200 of our regular episodes, and thanks to all the team behind the scenes who have helped put that together, but also all our guests and all our listeners out there too. Pretty significant achievement.
And a thank you to you, Matthew. The podcast was your brainchild, so
congrats.
It's
I just turn up now and talk. So I'm definitely not the person doing most of the hard work. But while we're thanking people, it's a good opportunity to thank people who do help support this show and all the other great things at the Passive House Accelerator.
Absolutely. So I want to start by thanking our sponsor of the week, Source 2050. And so they are making everything possible for us here at the Accelerator this week as a sponsor of the week. Also, a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, StoCorp, and Zola Windows. And thank you to our champion sponsors, Bewizo, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050.
Yes, thank you very much to all those people, and particularly Source 2050, who's the sponsor this week. Now, this is the last opportunity to give your contribution through our SpeakPipe voice message for this particular series that we're doing on cooling and summer resiliency. So this is we're heading towards the end of that series. Hopefully, we will be doing more of that SpeakPipe in the future, because it's great to hear from you listeners out there and give you the chance to ask a question or share a comment. But for this week, we would love it if you could share a story about how you're keeping cool, whether it's something you've figured out yourself or some DIY solution of how to keep cool in summer, or some other technology that you know of or a design feature. And share it with us. It'd be great to hear from you. Is there anything else that people need to know about that, Zach?
No, just go to the link in the show notes, and you'll be directed to speakpipe.com/passive_house_podcast. And that's where you can record your short message for us.
Awesome. I know that Kara's received a few of those already. She's compiling those, and we will be doing a special episode coming up featuring those and responding to them. So if you want to be part of that, now's your chance. Okay, well, let's jump into this week's interview. It's a bit of a long one, but I had a really good time talking with a friend of the show, Andy Marlow, from Australia, and I thought it was very appropriate to reach out to various designers in Australia who have some experience now working in warmer and even hot climates. We're starting to see more of that, all the way up from Sydney right up into Queensland, where we do actually get some tropical climate zones, so very hot and humid. And there are now some certified passive houses completed up in Queensland, and they do get right into that sort of tropical type environment up there. So they're dealing with high temperatures, prolonged high temperatures, and also extremely high humidity. So I've been interested for quite some time in what Australian passive houses are starting to look like. I'm pleased to say that there is no one look. There's lots of variety there, but there are some common features like shading and thinking about where insulation is needed and how much insulation. So we dive into a little bit of that. Andy's got some experience along with Talina, and also very involved in the passive house scene as well. So he gives some insights into how they're dealing with hot climates and resiliency in the Australian climate. So here's my chat with Andy Marlow.
And a quick reminder for folks who live north of the equator that in Australia, north faces the equator, just like south faces the equator for us up here. So when you hear north, think south when it comes to windows and shading and heat gain and all that.
Andy Marlow, friend of the show. I think you might be getting up there as one of our more regular guests. So welcome back.
Thank you very much indeed. Always fun.
So it's a little bit chilly where we are at the moment in our part of the world. And you've had an exceptionally cold winter, haven't you, this year?
By our standards, yes.
By your standards, yeah. But you had a bit of a cold snap a couple of weeks ago.
We did indeed. Cold and very windy.
Counter to the rest of the world, we're talking about summertime at the moment because things are getting hot everywhere. And you've certainly experienced your fair share of that in Australia, and it's getting increasingly warm. But I am seeing more and more designs, including passive house designs, that are working, well, at least it appears to be working quite well. So I'm really interested to get your perspective on that. How would you sum up how your colleagues are dealing with designing passive homes for the warmer parts of Australia?
Look, I think the key thing is it's still applying all the same principles that are baked into passive house. It's arguably baking in a lot more of the stuff that is traditionally stuck in more of the passive solar world, and really it's a focus around shading.
Yeah.
There's a bunch of other things, of course, but resolving how you're going to shade your building well to stop the thing heating up is definitely the trickiest of things.
It does make a lot of sense, but it is also takes a little while to get there if you go through a traditional passive house training, which emphasises solar heat gain and optimizing your windows, certainly reducing the amount of heat loss from the side that's facing away from the equator. I don't recall a lot of focus in my training on reducing solar heat gain in the hotter periods. Is that something that you know of that's being talked about a lot, particularly for new designers, or is it something they sort of figure out when they start doing projects in those warmer climate zones?
Look, I mean, I haven't done the training for quite some considerable time, but but the people who work for us, we periodically send people off to do it. I don't think it's massively shifted. I think it's still a lot of the content is still quite focused on the original stuff that came out of Germany, and it's all just sort of evolved over time. I think the key thing, I mean, the designer training course was never enough in and of itself to let you go off and design a certifiable passive house. It was always part of that stepping stone journey.
Yeah.
So I don't think that's really changed. I think one of the hardest things, and it depends whereabouts you're designing for, and I guess to some degree whether you're local to that place. Like, we design stuff all over the country, but when you're designing stuff that's local, for a lot of people in Australia at least, and I know New Zealand would be pretty similar, everyone's so focused on trying to stay warm because their houses are so crap
Yeah.
that trying to get, and this is hard with clients, but for designers who haven't done it before, it'll be hard for them too. It's hard to get out of the mindset that I've got to make sure this thing stays warm. So everybody's inherently ends up focused on solving the problem of today, which is the houses are crap and everyone's cold in winter. Like, the famous line, coldest winter I ever spent was in Sydney, from from someone who's grown up in like northern Sweden or whatever it is.
Yeah.
So I think it's that mind shift that as soon as you build a certifiable passive house, like as soon as you wrap the thing up, put decent windows in it, put a sensible amount of insulation, and in our case, basically code compliant insulation in Sydney at least, then you've got no problem with the heating demand. She'll be right. It really will. She'll be right. It's our answer to everything in construction industry, but occasionally it's true. And then the big focus is, how do I keep the thing cool? And that, rapidly your brain flips into that being I won't say the be all end all, but it's certainly the hardest part. And as the climate moves and changes, obviously there's extremes of both ends of the spectrum, but the hardest one to resolve is always going to be cooling, because when the grid crashes and everything goes proper pear-shaped, like if it's in the middle of a cold snap, that's mostly manageable because there's generally some ways to make a bit of heat or put more clothes on. But in the middle of a mid-40s heat wave, which we get already, not often, like in one of those, like once you're naked, you're naked. Like there's only so many ways you can lose heat.
Well, and also some of those heat waves, it doesn't cool down, and I mean it cools down a little bit, but it might still be above 30 degrees Celsius in the middle of the night.
Yeah,
which
so
isn't really helpful for night purging.
No. So night purge, I have developed a strong habit of completely ignoring night purging for exactly that reason.
For all climate zones?
I model all of our buildings, or we, Envirotech, model all of our buildings with no night purge ventilation. We'll model it as well. We do test it to go, okay, what will happen? But I take it all out because two parts. One, people are unreliable. And secondly, the climate's unreliable. And at the moments you need it most, that's when it's not going to be there. So we like to see what the building would do without it.
And so does that mean that mechanical cooling is a requirement?
We've never done a passive house that doesn't have mechanical cooling in it. They don't, like, in terms of passive house compliance, they don't necessarily have to. Like, they meet the, most of them at least, I'd have to go check, most of them meet the no more than 10% overheating requirement. But I would, in our climates, even in the Victorian climates, in the colder places, I still wouldn't do a house that doesn't have mechanical cooling. I think it's just dangerous in terms of, well, actually, I mean, maybe not in the colder places, but in Sydney, like the heat wave, the health issues that come during heat waves are often related to sleeping or inability to sleep at night. And I think not having a way to put some mechanically generated coolant into a building is just not very clever, to be honest. Like it's just it's a risk. Yeah.
So that's worthy of acknowledging that that is essentially it's really likely to be a requirement for passive houses in the types of environments that you're designing for now and into the future, where we're anticipating longer periods of warm, dry weather. You need to be allowing for some mechanical cooling. It's not sort of a nice to have. It's you're going to have it.
Yeah, and look, we've, especially our earlier projects, like we've got a lot of clients who I would very lovingly describe as deep green, and a lot of them are just inherently opposed to the concept of air conditioning. And to be fair, we were for quite a long time.
Yeah.
But you come to realize that it's necessary, but before you get to that part, we've always needed some form of heating. So in our pre-passive house days, we used to do a lot of hydronic heating and do, whether it's underfloor, in slab, but would do these things to heat buildings, but not have a cooling system. And that, depending on the climate, that can be okay. But what we basically come to is the fact that we need some form of heating, some form of cooling is good. Air conditioners, for better or worse, are incredibly cheap in the scheme of the cost of things,
Right.
and therefore the fact that you need one isn't actually that bad. And then the next question becomes, how many, whereabouts are they in the house, and how do you deal with the distribution issue, which is a whole other can of worms.
Yeah. Are there other systems like chilled beams that are used in commercial buildings that are transferable to the residential scale, or is it really just for cost effectiveness, mini splits and reverse cycle air conditioning really being the best option?
This comes up about I don't know, it feels like every week, but it's not, probably every month or two with various clients. They are achievable. Chilled beams or chilled hydronics, chilled slab stuff, any of that sort of technology can work. It's never going to be as cost effective as air conditioners because the scale of those is just through the roof, and the efficiencies for manufacture are just beyond belief. But it also depends on climate. So we were meeting with a guy in Victoria down near the Ballarat office a few weeks ago, and he's doing hydronics in panels in ceilings. And in their climate, that'll be okay because in summer it's not very humid. Whereas if you did the same thing in Sydney, if you ran chilled water through a panel in a ceiling, you'd get condensation straight away. It'd drip onto your ceiling, and then you'd get mold. Yeah. So the thing in the more humid and warm places is that in order to have a chilled beam system, you then have to have a dedicated dehumidification system because you have to, and they need to talk to each other because
which is effectively an air conditioner anyway.
Well, yeah, but you need a dehum system because aircon's ability to dehumidify and not cool isn't really there. So you've got to pull the humidity down, so that when your cooling device provides the cool water, that it doesn't condensate on whatever the surface is.
Yeah,
and they need to talk to each other because they need to know that they need to control the temperature of the water in relation to the humidity levels in the air, i.e., all possible, complicated, and therefore at the residential scale doesn't happen.
Yeah,
but can happen. Just needs systems and tech, and everything needs to work. And therefore,
what about evaporative cooling? Does that have a place in a passive house?
Actually, we've never gone there. Evaporative coolers sort of ceased to be a thing. Adelaide would have, of course, have had them back when you were there, I would assume.
Every second house had a big box on its roof at one stage. With one of the biggest issues there was how much water they consumed.
Yeah, because, especially Adelaide.
Yeah, you're pouring water into a big fan unit on the roof and drawing that down and relying on the phase change of that water, but massively increasing the humidity of the air.
I think your airflow through the building and the fact that the way that they were at least done, maybe they can be done better. The air leakage associated with them is through the roof. So I'm not sure that you'd get I don't think it'd stack up.
No, I would be surprised. Because
and the other,
I can't see it working that well with the other systems. So
they also used to be really common in Canberra as well. Yep. And they started to move away from them because it was always reliant on it being hot and fairly dry. Yeah. And while that is still a lot of Canberra, it's also sometimes hot and not dry, and they don't work very well then. So they're also quite humidity dependent, and that's becoming problematic as well. So I think they're kind of cactus, really.
Of course, we should also mention ceiling fans, which are very effective and very, very cost effective. And I know even if you are using mechanical cooling, nothing like ceiling fan, just to have a little bit of movement can go a long way to improving comfort, which even if you're getting close to that 25 degrees temperature, depending on the humidity, I know comfort's a whole matrix of other factors as well, like direct sunlight, glare, humidity, but also just a little bit of air movement can make a massive difference. So, and that is a trend that I've seen over the last probably decade, is fans are becoming a bit of a design feature, becoming a bit more aesthetic, some pretty nice looking blades, but also other technology around, making them quieter and a nicer feature rather than just, I remember them being very utilitarian really and kind of ugly.
Oh, for sure. They've definitely come a long way. I guess they've been part of our solution for a very long time. Part of it is because we didn't used to do air conditioning, and therefore the ceiling fan was, the closest you got to mechanical cooling. It's the movement of air across your skin will make you feel 3 to 4 degrees cooler than it really is. Therefore, I guess what it really illustrates is your comment about thermal comfort is about perception. And whether you're hot doesn't actually matter what the temperature gauge says, it's how you feel. Everyone feels different, which is lovely and also incredibly inconvenient. They really do help. And we start with them in every project. Some clients, for various reasons, don't like them. We've got one client at the moment who actually just absolutely cannot stand the feeling of movement across his skin, of air across his skin. So that house won't have ceiling fans in it because you just can't cope with it on a sensory level, which is, is the way it is. Different people. They are very pretty.
Say, it's a reflection of, designing a building is relatively simple until you put people in it. You've got to account for behaviours and preferences. You mentioned 10%. So 10% is relevant. Is 10% relevant? What's that all about?
I'd say not really. So 10% is the Passive House Institute's number percentage of hours of the year over 25 degrees C. That's their requirement for certification if you don't have mechanical cooling. I think there's wide agreement that a building without mechanical cooling that overheats 9.9% of the time, which is whatever that is, 800 and something odd hours of the year, probably isn't a great design solution. There's huge debate about what number you should be aiming for. I'm not convinced that the number really matters. I think you need to get it as low as you practically can. As soon as you've got the cooling in there, then you're very much back on how much energy is it going to take to keep the building cool? Lower, obviously, less overheating is better, but I'm not sure that saying 1% or 2% or 5% really, I don't think there's an answer to that. I think it's an interesting debate to have at the pub, but I don't think you can really have a hard and fast rule. And I mean, partly because everything depends. They're monthly averages. So on a hot month, your 1% is 2% anyway, or 3%, or whatever it might be. So I think just do better is probably the mantra for it.
I mean, I understand the need to have a benchmark somewhere. So it's a useful guide, but I have heard a lot of people say that 10% is way too much, and it also it's never as clear cut as that, because if you're spending a lot, months, could be 3 months, December through February at 24 degrees. That's too hot. It's too uncomfortable. You might all that time that you're very, very close to 24. Anything above 22, it's getting technically pretty warm. I mean, I know people do acclimatise, and it does depend on those other factors as well, like air movement and humidity. But it may just be scraping along slightly below that, and also it might be far exceeding it for short periods of time. So you get both of those extremes. But like I say, I think it's useful to have a benchmark and for people to have something to go for as a target. I know that we focus on 7, 5, and then 3% for Homestar rating, because we feel like 10% is too much.
Oh, look, I totally agree. And we use the number all the time, whatever, not the 10%, but whatever that answer to overheating is. We use it all the time as a design tool and a communication tool with clients.
How does that conversation go? Because Australia now has a requirement for considering overheating as part of your code compliance, your building code, kind of. You can talk about how that all fits together. But that's that puts you among a very small number of places around the world that have a requirement in the general building code. So outside of passive house, are people aware of such a thing as overheating, and that then it can potentially be designed for?
Well, there's people, and then there's our clients, which are quite different. But so
I'm talking about normal people, not your clients.
Exactly, normal people. Not that our people aren't normal; they're just very special. So at a national level, in a code compliance sense, what changed last time the code changed? So the NATA's system, National Home Energy Rating Scheme, used to have just a single number for energy use that you had to meet, or star bands, and in order to be 6 stars or 7 stars in a particular location, because it varies by location, which I think is a bit daft, you had a target number for total heating and cooling. What they've done now is they've split that, so you've got a maximum heating amount, you've got a maximum amount for cooling, and you've got a maximum total. And the maximum total number is not the sum of the other two. So you've got to be better somewhere, whether it's on heating side or cooling side or a bit of both. But what they were trying to do, and New South Wales had done this previously anyway, so they were sort of just taking their idea and running with it. Good idea. What they're really trying to do is stop having houses that are massively skewed to be good in winter or good in summer.
Yeah.
So they're trying to kind of make them generally better. So the principle behind the code is really good. The software is still incredibly good, and the tool behind it's incredibly good. The settings are stupid, and the way that the whole system's set up doesn't make any logical sense in the real world. But apart from that, it's really good.
But you do have it in there, and that's relatively recent, isn't it? Because your code gets updated every 2 years?
Every 3 years, but then the code, so it's a national construction code, but the states are in charge. So the states then decide when they're going to enact the new parts of the code, and they pick and choose.
Right.
So Western Australia will do it sometime in the late 2070s, I think. New South Wales is there already. Victoria's going next year. This is the 2022 code. So the earliest that anyone adopted the May 2022 code was October 2023. So the whole thing is a complete schmozzle, but it's the nature of the state-based system that Australia has that makes this the way it is. So, yeah. But it's in the code. It's just not necessarily legally required, depending on which side of a line of a map you sit upon.
Yeah, but I think that is interesting that it's there, and that means that people are even aware of it. Because part of my challenge here is the conversations that I'm having talking about the benefits of just energy modelling in general, is having an indication of the likelihood of a home to overheat. And that becomes a much longer conversation if that's not something that is considered at all. So I think that's the real benefit of having it in the code, because at least it raises the awareness in the general public.
Oh, I totally agree. It's a great thing to be in there. I'm, I guess, sledging all the other bits around it, but the concept of it's really, really good.
Yeah.
And for
certain
buildings,
it's a key part of resilience. And like you said before, overheating becomes a bit of a health issue. So it's something that should be in there. It can be dangerous to be having houses that are too hot for too long.
Oh, yeah. The numbers of people who die in heat waves in various places around the world are pretty stratospherically high. And in most places, it's higher than it is for cold snaps, mostly because most places have better houses. I
want to come back to design strategies. You talked about shading. There's also quite a lot of windows have come a long way in recent years, not just in terms of the insulation properties, but what's the market like there now for different specifications of glass? And I'm thinking things like solar heat gain and laminates, coatings, that sort of thing.
It's improving. It's definitely better than it was when we started falling in this rabbit hole. We're still mostly, for cost reasons, importing. Depends on the window type. So for timber windows or timber aluminium windows, we're still importing them. The local market has not yet started to manufacture them in a cost-effective way. There's a couple of people who are getting closer. So it's been pretty interesting in the last year or so to watch. There's a company down in Victoria who have got all the gear, and are doing the aluminium facing, and their costs are getting closer to where the import versions are.
Yep.
And new PVC windows they're readily available and fairly cost competitive now as well. The glass is interesting because it turns out in Sydney and North, well, in a lot of places, we're using fairly low G value glass. So again, we're back to it's not that hard to keep these buildings warm. It's pretty hard to keep them cool. So we're looking at G value glasses that are down at like 0.3-ish. And when we get local windows, it turns out that all of that glass, most of it's coming from the States, because that's where they make the ones with the low E coatings that we need. So the glass, that low G value glass is actually quite expensive when bought here, and that's part of the reason that the imported windows are still quite cost competitive, because their access to cheaper glass is apparently what keeps their costs down versus the local stuff.
Yeah. And when you say low E there, are you referring to low E coating on the appropriate surface that reduces the solar heat gain, that optimizes for summer?
Yeah, basically. I'm mostly worried about keeping the building cool. So,
and then does that impact your winter heating demand when you're doing your energy balance?
Mm-hmm. Oh yeah, it does. I mean, from a principles point of view, when we're looking at our passive house numbers, so we're gunning for 15 for heating, and our cooling numbers change because of the humidity requirements. So Sydney's 17 rather than 15 because there's a bit of dehumidification supposedly needed. But I'm trying to run those heating numbers at about 13 to 14. Like, I'll run the heating numbers up in order to get the cooling numbers down.
Right.
So a lived experience of the buildings, because at various points our clients let us go and stay in their houses, but also just talking to them afterwards. Most of them are comfortable mostly at 19, some even at 18 degrees. So all those numbers are based off 20 degrees as a minimum.
Yeah.
So we find that a lot of them don't even run them at that level. Some do, but a lot don't.
Yeah.
And therefore, those heating numbers, I'm not that phased. I'm trying to clear the hurdle because the hurdle's been given to me. But I want to just scrape over the heating one because I want to romp it in as far as possible on the cooling, because we know that cooling is harder and going to get harder over time.
Yeah. And what about shading? Are people doing anything, or are you guys doing anything for either fixed or movable external shading?
Quite a bit. Obviously, massively depends by project. We've always been people who put eaves on buildings. Not nearly always. They're incredibly helpful, unsurprisingly.
Yeah.
But what we've learned over time is, well, basically they're not necessarily enough. So firstly, your orientation needs to be fairly square to north. So as soon as you start skewing away from north, those overhangs, so eaves in particular, so anything that's horizontal in nature as a shading device, the further you get away from north, the less effective they become, which is just a product of geometry. So that can be problematic. If you're doing a house in the middle of a field, it's generally okay because you can mostly orientate the building as you want. But as soon as you're in the middle of a city, you get what you get.
Yeah.
So therefore, we have been doing more and more external, operable shading. We've ended up doing a lot of the blinds, just the retractable roller blinds that come down across the face of the glass. There's basically nothing more effective in terms of reducing heat gain.
Right.
They look pretty good if you detail them nicely. They're effective. In the scheme of things, they're fairly cost effective. But then we've also got a whole bunch of other shading stuff that we've done, not necessarily on passive houses. We've got a job we did out at Mudgee, which is pretty hot and pretty cold. It was also bushfire prone. So we did these massive ColourBond metal clad shutters that basically lifted up and down on a whole bunch of pulleys and wires that you could adjust. You can do anything you like. But you need something. And we're increasingly coming to the point that you need, if it's not due north, you probably need something operable. Obviously, it depends on the size of the window.
Yeah.
Those
roller shutters, are they European, or are they coming from places where those shutters are primarily designed for things like snow and storms and keeping it warm?
We're mostly buying those blinds through the people we get the windows from, because they get them in Europe, throw them in the container, and they're about half the price they are if we buy them here.
Wow.
When we buy them here, they're still basically the same stuff. So
are they insulated?
No, they're just a fabric. They're just a fabric blind.
Right.
But they knock out, depending on the fabric itself, they knock out 80% of the solar heat gain. So because it's bang up against the glass. I mean, the other thing that we came to realize just through modeling and paying more attention to how heat moves through glass or gets to the glass to move through it, even when the window is really well shaded by an eave, the radiation that bounces around, there's still about 40 to 50% of that will still bounce through your window, even if it didn't hit the window. So what that brought us to is that basically glass area, regardless of whether it's shaded, is a massive issue. Yeah. So you can have huge windows, you can shade them so the sun never hits them, which is actually quite hard depending on the orientation, but you'll still get a heap of heat gain through that window just because it's glass.
Yeah.
Overglazing's got to be it's a bit of the elephant in the room when it comes to overheating. Right.
Which I guess is another design challenge when you've got people who are being told that indoor-outdoor flow and massive floor-to-ceiling vistas is desirable. Just finally, I know that you also got fires are a thing in Australia. That is also something that I think is pretty well covered in your building code. Certainly in some locations, you have some requirements around dealing with embers and keeping. Well, how is it worded? The risks that you have to design for.
There's a system of, I guess, classification of the site itself. So there's a bunch of ratings that have this BAL number attached to them, which is bushfire attack level, and it goes from like low all the way to a few numbers to 40, and then FZ, which stands for flame zone, which is pretty self-explanatory. So depending on where you sit on that scale, depends on what you have to do. Ember protections is bedded into all of those levels because embers are mostly the thing that make buildings burn down. Once you get into flame zone, you end up, there's a couple of ways to do it, but the only cost-effective way to have a crack is to have bushfire shutters on all of your doors and windows. The practical thing is they're expensive. They're big and they are insulated because they've got to withstand the fire tests that they do to get the compliance certificate. And therefore they're big. They're hard to make look really good because the head box is like 250 mil square. But it's all doable. I mean, the key thing with the bushfire, with the whole system around designing and building for bushfire protection is, and it says very clearly in the standard right at the top, it's like, this is no guarantee, regardless of what you do, that your house will survive because it's a natural event and therefore it is what it is. What's interesting is that it's really about protecting, it's about how you build the building. It doesn't say anything about air infiltration as such. And it doesn't say anything about, I guess, the side that we've ended up becoming quite interested in, the whole passive house community here, really, around air quality inside buildings during bushfire events that may not necessarily, it's not that there's a bushfire in your backyard. The bushfire, I mean, when we had the really, really bad fires back 2019, 2020, those bushfires were like hundreds of kilometres from Sydney, where I live. And yet it was like the sky was black or red or both. And you could taste the smoke.
It impacted here in New Zealand. It changed the colour of the sky and the you could smell it here as well, which is quite incredible. We have covered, we are covering that in this series, the options out there for scrubbing and also the benefits, of course, of Passive House and dealing with that sort of thing. But in terms of the detailing of Passive House, does that make it harder or easier or not, or neither, for ember protection? Does Passive House make a difference there?
It makes a little bit of a difference. So the internal air quality is so on that front. Then having an airtight. There was good research done during those fires by Harley from Logic Case and Cameron Munro as well. They basically proved, because they had sensors in a whole bunch of houses around the country at the time for other reasons, that you're better off in an airtight house than not in an airtight house.
In terms of air
quality. Still wasn't necessarily great in the airtight houses, but it was much better. From a bushfire protection point of view, your airtight envelope is obviously helpful from that air quality point of view. From your house not burning down point of view, in a way, it's not a huge help, because in theory, an ember could still sit on your weather barrier and catch fire and send the whole house up.
Right.
So it's that ember protection is normally, or in bushfire land, it's about keeping those embers away from anything that will burn.
Yeah.
But things that end up having an amazingly convenient crossover. So regardless of bushfire or not, like in a timber frame building, we always have a ventilated cavity on our walls and roof. And therefore, that ventilated cavity has always got something that stops bugs and other crap getting into those gaps, and yet still let it be ventilated. So the only difference in bushfire land is that there's a legal requirement that those holes are less than 2 millimeters. So in a normal job, those holes are probably slightly larger because you want a bit more ventilation. But therefore, most of the people building a passive house are building something that probably isn't a million miles away from a bushfire resilient house anyway, because of the nature of the detailing.
Yeah.
So you're sort of, like most things with passive house, the quality level, by the nature of meeting the standard, is solving a lot of other problems at the same time. Can I mention one other thing before we wrap up that I've realized we didn't get to, that's a bit of a brain fryer for the passive solar people, well, in our climates anyway. This is very climatically dependent. But for quite a long time, we never insulated underneath our concrete slabs. And that always gave us a bit of a penalty in winter, because it obviously made the slab a bit cooler than it would have been otherwise. But it always gave us a big benefit in summer, because you get the cooling benefit of the ground beneath you.
Mm-hmm.
And as we have been modeling things, I guess, and in PHPP, and then in particular as we start to model in future climate scenarios, so we've just been using that blunt add a few degrees to the temperature thing inside PHPP. When you do that, you suddenly realize that in a warmer climate, the ground becomes a heat source in summer itself. And therefore, you need to start insulating under your slabs. Otherwise, you're going to get heat coming in from underneath as well. And that is quite different to what I was taught as part of, I guess, the passive solar background that I have, and is just incredibly uncommon in our climate.
Does that mean... is that across the board, or does that mean that you need to be doing very site and climate specific design to check out whether it's going to be net benefit or not to insulate the slab?
Obviously, in PHP, you can obviously check it out pretty quickly. You'll get different answers in different places for sure. I guess what I'm thinking is beginning to happen is that in the Australian context, the place up the coast where you go from insulating a slab to not insulating a slab, that's shifting. So previously we didn't insulate anything in Sydney, whereas now some we are and some we're not. It's still a bit line ball, to be honest. And
I remember that from talking. Was it Chris Nunn, his house?
Possibly. His is not insulated.
Yeah, well, I remember that being a feature of that, because I was asking him specifically about the slab, and that was a big decision, because there was a bunch of firsts, I think, for his house, which is in Sydney, and that was one of the things the modelling showed, that it was actually beneficial to it was either beneficial or there was no significant benefit to insulating the slab because of that. But what you're saying is that is likely to change as the ground warms up, like over a long period of time. And I guess that's a function of longer extended periods of much warmer weather, and probably would that be a bit of a urban heat island effect as well?
I guess so. I mean, it's the ground temperature is a product of the temperature around everything. So if you're in a city, it's more likely that that's going to build up over time, and therefore you'd end up with a high ground temperature as well. So,
I mean, I guess all of that points back to the importance of modelling and site-specific modelling, not making too many assumptions, but looking at the data, and also looking at future data. Are you starting to incorporate future data climate files into your modelling?
We've only been using the increase the temperature tool inside PHPP itself.
Right.
We had through the Passive House Association a while back. We did get some of the proper future climate files, but I found that became more problematic because you then had to justify the one that you'd chosen.
Right.
Whereas all I do now is I just pick 4 degrees increase and 4.
Wow.
But it's a discussion point. So I think the modelling thing is true, right? The modelling is incredibly valuable and it should be done and it's incredibly useful, but it's also always wrong.
Yeah.
But it's a useful discussion point, and that's where I find the 4 degrees is quite easy. You're like, I'm not saying that that's where we'll end up.
Is that 4 degrees in summer or across the whole year?
What it does when you look at it, it adds 4 degrees in the peak of summer, and then it adds a bit less than 4 degrees on the other months as well.
Right.
So what you see is that your heating numbers come down and your cooling numbers go up. That's no huge surprise. You're really looking at it to see whether the relationship between how much the heating ones go down and the cooling go up, and just you're trying to understand to what extent your building is skewed more for winter or summer.
Yeah.
But it's the large number is somewhat helpful in the discussion with clients because to some degree you get away from the debate about whether the 4 degrees is correct or not.
Yeah.
And you're straight into talking about, so when it's really bloody hot, this is how your building's going to perform.
Yeah.
And therefore, because normally it's in the context of, and therefore we would like to nearly reduce the size of your glazing or spend more money on external blinds because we think these, especially east and west windows. So in passive solar land, obviously the focus was always on keeping the sun out of the big windows, which were nearly always to the north. But what we've noticed, which makes total sense, is that when you've got a lot of, people are always very focused on the west windows as well, because at the end of the day, when the building's already heated up because it's like a sieve, then the western sun really pounds and everyone feels that. It turns out that the western sun's exactly the same as the eastern sun because it turns out that the sun is still the sun. But when it comes from the east in a really airtight building, you can overheat the house fairly easily by 7:30, 8 o'clock in the morning in summer.
Yeah, right.
And if you're, and we're back to now, this is occupant behaviour and expectations and all that. Once it's hot, it has a tendency, unless you do something, to stay hot. Yeah. And therefore, east is as important as west, but that is not ingrained in anybody's thinking.
And more so in an airtight house.
Yeah, because
and really well insulated house. Yeah.
Because when you had a lot of heat gain in an old passive solar house from the east, the air temperature wasn't generally that warm at 7, 8 o'clock in the morning, and the building leaked like a sieve still. Yeah, so it didn't matter that you got the heat gain early because you lost it.
Yeah, it might leak out.
Itself.
Yeah. Yes. Fascinating. It seems like we could talk on this stuff for quite a while, Andy. It's great. There's so much valuable stuff. Really appreciate you having me back on the show. No doubt we'll get you back again to talk about some more issues. I really hope that's been useful. I think it is, because this is not just an Australian issue, and I'm really pleased that lots of people are talking about and comparing notes on this stuff from around the world, because we need to be doing that. So thank you. that was Andy Marlow of Envirotecture. Of course, a frequent guest of the show now. Always love chatting with Andy and some of the rest of the team in Australia to find out not just what they're doing, but also some of the rest of the community there and some of the other great designers and also really fantastic builders who are utilising Passive House to deliver homes that are healthy and comfortable all year round, and some really interesting design philosophies, I think, dealing with those really high temperatures and also high humidity in those climate zones. So I'm really hopeful. Part of the reason I really wanted to get Andy on the show was that I see a lot of similarities between the southern states of the US and across in Spain, lots of other places around the world, even Southeast Asia, where the climate's very, very similar. Now, Zach, you pointed out that when we talk about north-facing, that's equivalent to south-facing. We're talking about facing the equator. But one thing we have in common is that obviously the east and the west. And that's a bit of a trick, I think, for beginners, because that westerly-facing windows are often the source of a lot of overheating, which we're seeing here in Auckland. Lots of glass on westerly-facing windows tends to create pretty uncomfortable nighttime temperatures because it just heats up in the afternoon. And it's also very hard to shade for because the traditional horizontal shading above the window is not really going to have much impact when you're dealing with low-angle evening sun. So there are some absolute commonalities there. Any other sort of things that sort of highlights for you?
Well, I mean, his quote of that overglazing is the elephant in the room when it comes to overheating goes right along with what you just mentioned in terms of the challenge of west-facing, and as he pointed out, east-facing windows as well. And that is only exacerbated by the fact that we are needing to shift more and more to thinking about overheating as opposed to overheating in the summer as opposed to the more singular focus on heating in the winter. And as I thought it was a really interesting kind of data point that he's finding in some places that the ground is becoming a heat source during the summer. So we're in a space and time where so many things are in flux as everything changes in so many ways, in terms of technology and energy mix and all sorts of stuff, but also just in terms of the realities of the climate.
By 4 degrees, apparently.
Yeah, right.
Which is kind of scary.
And I mean, it's so hard to know and predict and forecast what the actual degrees will be. But when you go through something like a heat dome, you get a stress test, and I think we do not properly we're not yet stress testing our designs the way that we need to ensure that we can survive and be thrive during those times. Yeah.
So, Mary, what were your takes?
Well, I found it interesting that he talked about the humidity changing as well as the heat when he was talking about Canberra, I think, because it's not something that most people think about. They think, we're having rising temperatures, but different areas might have different humidity also than what they're used to, which is something we're not stress testing our buildings for. But also the other thing that struck me is that he talked about that there's still I think it was the east and west facing windows or all windows, that there's a lot of, he said 40 to 50% of the radiation is still bouncing around and will get in through your glass, even if it doesn't hit the window directly, which I thought that was really interesting and kind of brings us up, as he said, up against that indoor-outdoor flow that is so appealing to so many people.
Yeah. So that's the influence of that diffuse light, that even if you're not getting the direct light, if it's just... And I've experienced this back in Adelaide. The sky, there'll be places like this in southern states of America that are very flat, the sky is huge. Like it's just so much sky, and it's not that there's more sky. It's just that aren't as many tall buildings or hills in the way, and with such a large area of available sky, there is just so much light. And even if you have no direct light, there's just light bouncing around everywhere. It's and everything's hot. You get those days when the pavement's hot, the road's hot, the earth is hot, and it's really, really hard to get out of that heat in that situation. I think that question around the heat from the ground is a really interesting one, and I remember talking to Chris, who we did discuss that specific case where the energy modelling showed that perhaps insulation in the slab may not be the best thing. I don't know what the answer to that is except for energy modelling. I think it all points to the value of energy modelling that is site-specific and climate-specific, with the allowance of starting to use future energy models and not thinking that what you're designing today is necessarily going to be in the same situation as 20, 30, 50 years ago, because you're much more likely to be facing different climatic conditions. And on the point of humidity, that's something that we're really facing here. Our biggest heat wave right now is in the ocean. And what that's doing is that quite dramatically increasing the sea temperature. Because New Zealand's a long, skinny island surrounded by water, that's having a real impact on increasing the general humidity of the whole climate, which is having all sorts of impact on rainfall events and those sorts of things as well. But it means that ambient humidity is never below 60%. So vapor control, moisture control, air control is almost as important as thermal control, particularly when you get into those tropical areas.
More complications to deal with.
Yeah, more complicated and kind of a different philosophy. It's just in some ways when you're predominantly designing for a warm, a cold climate where you're heating. That's relatively simple because you can where the heat flows, the moisture goes and it's sort of going in one direction for most of the year. Where you've got to deal with either that flow being in the other direction or it potentially changing between seasons, then it does get a little bit more complicated when you're trying to control all those things at the same time. And you should be controlling those things at the same time. You have to have thermal control, water control, vapor control, and air control. And that's something that building science talks about is having all those control layers working properly.
I also really enjoyed the conversation about bushfire, both hardening houses to bushfire events, and then also the conversation about indoor air quality and bushfire smoke, which resonates clearly with what we've been talking about the last couple of episodes. Yeah. I wanted to direct people to Mary's excellent video on the Reimagine Buildings YouTube channel called 10 Steps to Hardening Your House Against Wildfire, where she talks about all the improvements that she made to her own house in California and goes through just step by step the key things to be thinking about.
Cool.
So we'll include a link to that in show notes.
Yeah, and of course back to all the rest of the series. We have been doing this series on keeping cool and also focusing on resilience. There's some great stuff in there. So if you're just joining us, make sure you go back and check those ones. All right, anything else to wrap up on that conversation? I know we covered quite a lot of information there.
The importance of exterior shading. I mean, for the bushfire, they had to be metal, but he also talked about using fabric blinds as well. And it's still something that people don't think about enough.
There is a table hidden somewhere in the Passive House, the PHPP manual, that shows the difference between indoor and outdoor shading and the different relative impact. It's around 10%. The effectiveness of blinds on the inside is about 10% of the effectiveness of the same blind on the outside. So looking at it the other way, the difference is really 90%. It's a massive difference if you have the same piece of material on the outside of the window that stops that heat from getting in the first place versus a small benefit you get from having a blind. And it's much more common for people to have blinds on the inside because they're easier to operate, they're slightly cheaper, they don't have to be weatherproof. But you end up with the heat sort of getting inside the window and then bouncing around between the glass and the blind, and a lot of it diffusing and still conducting into the house. So, yeah, I think that's a really important point about external shading. I'm a big fan of external shading. All right, we should probably move on because this episode is probably getting a bit long. We would love to hear from you all out there. Don't forget, we have got the Speak Pipe open. It'll still be open for this series for a little while, but this is getting towards your last chance to share your stories specifically about keeping cool and resilience. Particularly if you've done something, a bit of a DIY project and figured out a solution, whether it's better indoor air quality, ventilation, shading that we've just talked about. Jump on to the link in the show notes and share your stories there. We'd love to hear from you. I'm also wanting to do a quick shout out for the Passive House Conference for New Zealand, which is coming up from the 13th to the 15th of September in Wellington. Very excited that our other friend of the show, Lloyd Alter, is going to be here in person as one of the keynote speakers. There's also some other well-known people like Jason Quinn, Joe Live, and we've also got a couple of other international guests joining us as well. So I'm really excited to be part of that. So that's coming up 13th to the 15th of September in Wellington. All right, any other notices, Zach?
No, stay tuned, though. We're about to fire up the Passive House Accelerator live shows on Wednesdays beginning in September, and we also have a major announcement coming at the beginning of September that I think people will be, I hope people will be excited about. We're excited about it, but more to come on that later.
All right. Well, thanks for joining us, Mary. Thank you, Zach. Thank you all for listening, and we'll be back again next week on Passive House Podcast.